welcome back. Now we're going to do some practice by finding critical points. So again, I'm going to use, for the first one, I'm going to write down the steps because I know that helps some people. Step 1, find the derivative. Step 2, set the derivative equal to 0. Step 3, solve for x. Step 4 is plug in those x's into f at x. And that gives you the critical point. So these are the 4 steps you need to do. Not too tricky. So let's start with number 1. So for step 1, we need to find the derivative. So f at x is equal to 9x squared plus 2. Okay? Step 2 says that we need to set the derivative equal to 0. So 9x squared plus 2. Well, looking at this, there's nothing much that we can do here to solve for whatever x is. Now we could use a quadratic formula, but once you do that, you'll realize that it's not defined. If you're familiar, the quadratic is the square root of b squared minus 4ac over 2a. Okay, so plugging in these values into the quadratic formula will also give you undefined. So therefore, we see that there's never a case when f prime of x, so the derivative, is equal to 0, which means it is always positive. And we're going to talk about that later, which means therefore, there are no critical points. Ooh, okay. Let's try number 2 now. Give it a second if you want to try it on your own before we do it together. Okay, so first step is find the derivative. Well, 1 over 3, x minus 1, and now we're going to subtract 1 from the top, which is negative 2 over 3, and the way to do this is you do 1 over 3 minus 1. Well, it's a whole number, so we can just say 1 over 3 minus 3 over 3, and gives us negative 2 over 3. Okay, a little side comment there. So yeah, we have 1 over 3, x minus 1, negative 2 over 3, and multiply by the derivative of what's inside, which is just 1. So let's rewrite this now. We have 1 over 3 times x minus 1 to the 2 over 3. Okay, well the next step says to set f prime of x equal to 0. Well, just to show you what happens if we do that, if we say 0 is equal to 1 over 3x minus 1, 2 over 3, we can multiply both sides by 3 times x minus 1 to the 2 over 3. Okay? But then we see that we end up with, again, 0 times anything is just 0. We get 0 is equal to 1. Well, that's not the case. 0 is never, ever, ever equal to 1. So we can't do this, okay? But it's good to check. What we can recognize is that this is a fraction, right? A rational. And we know that fractions have a certain rule, right? The denominator can never equal 0. Okay, so what does this look like? Well, we know that to find critical points, the derivative either has to equal 0 or be undefined, right? Well, we know that if we have 0 as the denominator of a fraction, then it is just undefined. So what we could do is set this fraction equal to be undefined in a way. Kind of informal, but you could say, well, when is this function actually undefined? When is there an error when you plug this into the calculator? What we do realize now is that, well, we need to set the denominator equal to 0. So 3x minus 1, 2 over 3 is equal to 0. Solving, dividing 3 by both sides, and then taking the 2/3 square roots of both sides, you end up getting x is equal to 1. What this tells us is that when x is equal to 1, the derivative is undefined. And we can check this. If you plug in 1 in here, we have 1 minus 1 to the power of 2 over 3, which is just 0, and 0 times 3 is just 0. So we end up with this case of 1 over 0, which means it's undefined. So when x is equal to 1, our function our derivative is undefined, and as such, x is equal to 1 is a critical point of f at x.